Hello, question 4 for the midterm asks us to find all values of A for which this matrix here is invertible. Now, if our matrix just had regular old numbers inside of it and we wanted to calculate whether or not it was invertible, the easiest way to do that, ordinarily, is to just row reduce it and check that its rank is full, or equal to, in this case, 4. It turns out that in this case we can actually do the same thing, but we just have to be careful when we're doing our row operations. In particular, we want to be really careful about dividing. We don't want to divide by anything that involves a variable unless, unless we kind of branch up the operations. And because when we're dividing by some expression that involves a variable, it could be equal to 0. And you can't divide by 0. So let's go ahead and do this problem in all its glorious detail. To start it off, we're gonna row reduce this thing, and then we're gonna see when its rank is full. To start off, we can go ahead and cancel off these leading entries here. It's pretty easy to do. Okay. It's just straightforward. Row 2 goes to row 2 minus row 1, row 3 goes to row 3 minus row 1, and row 4 is going to go to row 4 minus 2 times row 1. Resulting matrix is pretty easy. 0A minus A, and then 0, 1 minus A, and A, 0, 1, and this A here and this A here, we're getting minus 2 times this plus this, so we're going to have a minus A there, and then that's just a 0, so we get another A. Okay, now this is where we want to start off by worrying. We don't want to divide out by A here, unless we're very careful about our work, because A could be 0. Instead, what I'm going to do to help bypass that, I'm going to take this guy here, and I'm going to move him up top, so that I have a nice number to work with as a leading entry. So my next step is just going to swap row 2 with row 4. Alright, 1, 0, A, 0, 0, 1 minus A, 0, 1, 1 minus A, and 0, A minus A. Great. Now that I have that, I can use this 1 to cancel off these leading entries, where when I'm canceling off this leading entry, I just have to involve the letter A. So row 3 is going to go to row 3 minus row 2, and row 4 is going to go to row 4 minus A times row 2. That'll help us out. So this first row is easy, and the second row is also easy. 1 minus A. This guy, all right, we're going to have a 0 here. And now if we do minus 1 times this row plus this row, we're going to get an A plus 1 minus A, so it's going to cancel off and just give us a 1. And then here, when I do minus 1 times this row plus this row, I'm going to get minus A plus A. That's 0. So this third row here is really nice. Now over here on our fourth row, we're going to get some zeros. And then when I do minus A times this plus this, that's going to turn into A squared minus A. So this is a really ugly entry, but hopefully you guys can see it. Right. And now this entry here, I'm going to do minus A squared plus this, so I'm going to get A minus A squared. That's really ugly, but hopefully you can tell what goes where. Now we're almost done. We lucked out and we got this 1 here. Now we can just use this 1 to cancel off this entry, and then our result should be in row echelon form. So here we go, the last operation. Row 4 goes to row 4 minus, and it's really ugly, A squared minus A times row 3. Alright, and what's our resulting matrix? Huzzah! Well, the top 3 rows are going to stay the same. 1, 0, A, 0. 0, 1, minus A, 0, 0, 1, 0. And on this bottom row, we're going to cancel off this entry, because that's what we made it to. And then luckily we have the 0 here, so all we have to worry about is A minus A squared. All right, so now let's think about what we have. We have a bunch of 1s here in our leading entry, so these are never going to change. These rows here are always going to have a leading entry. The only row that could possibly not have a leading entry is this guy down here. And if it does have a leading entry, then we know that the rank is full. And if it doesn't have a leading entry, in particular if this element right here is 0, then we know that the rank is only 3. So what we get is that if A minus A squared is equal to 0, i.e. A is equal to 0 or 1, you get this just by solving this. This is A times 1 minus A. It has 2 roots, which are 0 and 1. Okay? So if this equals 0, i.e. A equals 0 or 1, then the rank of A, big A, equals 3, which does not equal 4, which would give us full rank. This is equal to, for example, like the number of columns. Okay. So A would not be invertible. Ooh, E kind of messed up. All right. However, if A minus A squared is not equal to 0, i.e. A does not equal 0 or 1, then the rank of A is equal to 4, which equals the number of columns, for example. So A is invertible. Ran out of a little space, but there we are. So this is question 4 in its full and glorious detail. If you have any questions, you may ask me in class, or you can post stuff in the comments below and we can answer it that way. Thank you.